Have you ever thought about the nature of reality and the universe we live in? Is it as solid and predictable as we believe, or is there something stranger going on? Let's take a moment to consider our conventional understanding of the universe. It's based on the principles of classical physics, where everything is as it seems. In this paradigm, particles have set properties. They behave in predictable manners, following well-established laws of physics. It's a comforting thought, isn't it? A universe that behaves itself, where everything is in its proper place, following the rules. But what if I were to tell you that this view of the universe, as reassuring as it may be, might be an oversimplification? Enter the realm of quantum mechanics, a field of study that turns our classical understanding of the universe on its head. In the quantum world, nothing is as it seems. We step away from certainty and embrace the unexpected. Here, particles do not have fixed properties. Instead, they exist in a state of flux, their properties uncertain until the moment they are measured. But here's the real kicker. The act of measurement itself fundamentally alters a particle's state. It's as if, by merely observing, we change the very nature of what we're looking at. It's a concept that's as baffling as it is fascinating, and it challenges our most basic notions of reality. Yet this is only the beginning of the journey into the strange and wonderful world of quantum mechanics. As we delve deeper into this realm, we encounter phenomena that are even more mind-boggling. But that's just the tip of the quantum iceberg. The real fun begins with something called quantum entanglement. Imagine two particles thousands of miles apart, yet connected in such a way that the state of one instantly affects the state of the other. This is quantum entanglement. Now let's dive a little deeper into this fascinating concept. Quantum entanglement is a peculiar phenomenon that occurs when two or more particles become inseparably linked. No matter how far apart they are, the properties of one particle instantaneously affect the properties of the other. It's like they are communicating faster than the speed of light, which, according to Einstein's theory of relativity, should be impossible. So, how do particles become entangled? It typically happens when they interact physically. For instance, if two photons are produced by the same atom, they might be entangled. This means their properties, such as their spin, momentum, or polarization, are connected in a way that isn't determined until one of the particles is measured. Now, imagine we measure one of these entangled particles and find it spinning clockwise. Instantaneously, its entangled partner, no matter how distant, will be found spinning counterclockwise. It's as if the act of measurement on the first particle decides the state of both particles at once. This has been demonstrated in many experiments, the most famous of which is perhaps the Bell's theorem experiment. In this experiment, entangled particles were sent in opposite directions, and when the properties of one particle were measured, the properties of its distant partner were found to be correlated, just as quantum theory predicts. This bizarre behavior, where the state of one particle is instantly mirrored by another, has no equivalent in our everyday world. It defies our intuitive understanding of how the universe works and challenges our traditional notions of reality. But let's be clear. Quantum entanglement is not some abstract theoretical concept. It's a real phenomenon that scientists have observed in the lab. It's a cornerstone of quantum mechanics, and it's paving the way for revolutionary technologies like quantum computing and quantum cryptography. Quantum entanglement challenges our traditional notions of reality, and it's not just theoretical. Scientists have actually observed this phenomenon. You might be wondering, have we really seen quantum entanglement in action? The answer is a resounding yes. The quantum realm, as abstract as it might seem, has been brought to life in several groundbreaking experiments. One of the most remarkable is the demonstration of quantum entanglement, a phenomenon so counterintuitive that it seems to defy our everyday understanding of reality. Let's take a step back and look at a few of these experiments. One of the first was conducted by Alain Aspect in 1982. His team fired pairs of photons in opposite directions and found that the state of one photon was instantaneously linked to the state of the other, no matter the distance between them. This was the first solid evidence of quantum entanglement, a phenomenon that seemed so strange that even Einstein referred to it as spooky action at a distance. Fast forward to the 21st century, and the experiments have become even more sophisticated. In a recent groundbreaking study, scientists managed to demonstrate quantum entanglement between particles with opposite electric charges. This was a significant step forward because it expanded our understanding of the types of particles that can become entangled. But what does all this mean? Well, at its core, these experiments are challenging our understanding of the very nature of reality. They're showing us that the universe at its most fundamental level doesn't behave like we'd expect. Particles can be linked across vast distances, their states changing in sync as if they're somehow communicating faster than light. And it's not just about understanding the universe. Quantum entanglement has practical applications too. It's the principle behind quantum computing, a technology that could revolutionize everything from drug discovery to encryption. So, quantum entanglement is not just a bizarre theory. It's a real phenomenon that's pushing the boundaries of our understanding of the universe. Quantum entanglement is more than just a weird quirk of the universe. It has some very real and potentially revolutionary implications. It is a concept that straddles the line between science and philosophy, between what we know and what we can only begin to understand. One of the most exciting implications of quantum entanglement is its potential application in the field of quantum computing. Today's computers, as advanced as they are still fundamentally binary, dealing in ones and zeros. But imagine a computer that could process information in multiple states at once, exponentially increasing its processing power. Quantum entanglement could be the key to unlocking this potential, enabling the creation of quantum computers that could tackle problems far beyond the reach of our current technology. But that's not all. Quantum entanglement could also revolutionize the way we communicate. Imagine a method of communication that is not only faster than anything we currently have, but also completely secure. This is the promise of quantum communication, a technology that leverages the entangled state of particles to transmit information. No more worrying about hackers or eavesdroppers. Quantum communication could be the ultimate in secure communication. Beyond these practical applications, quantum entanglement also has profound philosophical implications. It challenges our traditional notions of reality, of cause and effect, of the very nature of the universe itself. Is reality truly as solid and predictable as we think it is? Or is it, at its most fundamental level, a swirling mass of probabilities and potentialities, forever altered by the act of observation? Quantum entanglement shows us that the universe is far stranger and far more interesting than we could ever have imagined. It's a reminder that there's always more to learn, more to discover, and more to understand about the world around us. Thank you for joining us on this journey into the bizarre and fascinating world of quantum entanglement. We've barely scraped the surface of this complex and mind-bending phenomenon. It's a field that continues to challenge our understanding of the universe, and one that promises to revolutionize our technology and our way of life. We encourage you to continue exploring the fascinating world of quantum physics. Read, research, ask questions. There's so much more to learn and so many more mysteries to unravel. If you enjoyed this video and found it informative, please give us a like and subscribe to our channel. Share this video with your friends and help us spread the knowledge. Your support enables us to keep creating content like this and helps us reach more curious minds like yours. Remember, the universe is full of mysteries waiting to be discovered. Keep questioning, keep exploring, and keep learning. Until next time, stay curious.